This is the video replication for the weekly prep for week 10 of the course Quantitative Analysis, Applied Inferential Statistics. Today, I want to briefly discuss how we create and interpret scatterplots. The replication file, which is available on GitHub under the week 10 repository, requires only one package for this prep, ggplot2. We'll load the MPG data that's found within the ggplot2 package into a new data frame object called autodata, and then we'll reference that new data frame throughout the weekly prep. There are three questions. The first question asks us to replicate code that exists in section 3.2.2 of R for Data Science. In this first question, we have two continuous variables: displacement, which is assigned to the x-axis, and highway fuel efficiency, which is assigned to the y-axis. We're plotting them using the point geom, and we specified our aesthetic mapping within it. This geom was covered in week 2, so head back to the first lecture from that week if you need a refresher. When we execute this code, we get the following plot. There's a noticeable trend here. As engine displacement increases along the x-axis, the corresponding y-axis values for highway fuel efficiency decrease, and we get this subtle curve in our data. This makes intuitive sense. The larger the engine, the less efficient it will be. Before we continue with the weekly prep, I want to briefly introduce a new function, ggsave. This is how we can save our ggplot output. As I have it right now, ggsave will save whatever the last plot is that we've created. I've specified a file name and format, PNG, in double quotes. This will be saved to our working directory, which is automatically created when we make a new R project. We can also set the width and the height measurements that are specified by the units parameter. ggsave accepts measurements in inches, centimeters, and millimeters for units. Finally, the ggsave function allows us to specify the resolution by setting the dots per inches. The smaller the DPI value, the more pixelated the image will appear. The larger the value, the less pixelated it will be. 500 dots per inch is plenty for presentations and publications. To use ggsave in a function, we'll include it after the plot that we want to save, and then execute the code chunk. Once it's executed, the image file we want to create will be saved in our working directory. For question 2, we are asked to create a scatter plot of the highway fuel efficiency variable and the number of cylinders in the engine. The syntax is nearly the same as before, but I've swapped out the previous x variable for the cylinders variable. What we get is slightly less informative. The discrete x variable means that all of our data are stacked in columns. We can see that there are differences in the amount of variation between cars with different numbers of engine cylinders. This makes intuitive sense. A car with a larger number of cylinders may be a less efficient vehicle. However, the difficulty of interpreting this plot is an indication that it is not the best plot to use. A box plot, for example, with one box per discrete category, would be better suited for communicating these findings. The third and final plot makes even less sense. Again, we swap out the x and y variables for new variables, one for class and one for drivetrain. Otherwise, the syntax remains the same. The plot we get is not at all informative. The problem here is that there are a few unique combinations of class and drivetrain, and because a number of cars in each category share the same x and y characteristics, the points end up stacked on top of each other. The resulting plot is rather nonsensical. A bar plot would be far better suited for this task.